You might have seen one of these videos where Brian Leake claims that the equinox sunrise proves local sun. Or you might have heard Brian talk about this in Discord or on a YouTube debate.
This video is for the ballers that are three-dimensionally challenged who tell me our line of sight doesn't curve around the ball, or we're not looking at the GP of the sun that's on Earth.
Well, we will see who is 3D challenged, but Brian did get a few things right. Such as these three gummy men pointing due east into space that represent three observers watching the equinox sunrise on a globe. But Brian is also very wrong, because Brian does have a demonstration where the sun does rise from its GP on the equator. Let's listen as Brian talks about great circle routes.
Each one of these lines is due east, and they all converge at the equator, thousands of miles away, not millions.
And Brian is correct. Great circle routes from the observers at the terminator line do intersect at the noon sun GP on the equinox. Of course, Brian is also absolutely mistaken because these great circle routes are not due east. Yes, they start off at a heading that is due east, but when you start a new path anywhere along that original great circle route, you see that heading constantly changes as you head towards the equator. But Brian did get something right about the orientation of those observers to those great circle routes. Now here I've added three observers along the terminator line of sunrise, and their zenith is in alignment with the great circle routes. Now it's not that easy to see here, but it is quite easy to see when you look at it from this direction. So Brian is correct. The observed sunrise is aligned with those great circle routes. But I think you can see the problem here because these three observers are pointing due east into space. Not down at a sun that's sitting on its ground position on the equator, but let's watch as Brian pretends this is reality.
Okay, I got a black line right beside the pink line highlighted, our line of sight, our great circle. Okay, now just if I raise it off the ground, okay, that angle's not going to change. Look, I'm going to raise it, so we're right here waiting for the sun to come up. Sun comes up, okay, it's still converging, and look, oh shit, it's still on the black line, you see? Our line of sight didn't change. It's still right next to it anyway. Our line of sight did not change.
Well, the only real aw shit is what did Brian do wrong? Well, on one hand, he's claiming that the arms are still pointing along the 90 degree, and yet somehow they're also converging locally. Well, he's ignoring the fact that the angles actually do change as the string is raised, and of course, this is why the angles for the two outside observers are converging locally. So this absolute misrepresentation of sunrise on a globe is not proof of a local sun on a flat Earth. So who is 3D challenged? Because these are the lines that are pointing due east into space, and the two key words are into space, not along the surface of the Earth. So what else did Brian get wrong? Well, let's have a listen.
Does that latitude line look like 90 degrees or due east? No, it's not. The pink string line is 90 degrees. Any 90 from a great circle gives you a great circle.
Well, again, we have a situation where Brian is correct because if you look down from this angle, that great circle does appear to be straight. And it is also 90 degrees to the longitude line. But again, Brian is mistaken because if I just change the direction that we look at this, now the latitude line appears straight and it is the great circle that is curved. In fact, Brian even shows a straight latitude line in his video. And that latitude line is also 90 degrees to the longitude line. So again, if we look down at the globe at these angles to the great circles, they appear straight and the latitude lines appear curved. But if you look down at the globe at these angles, it is now the latitude lines that appear straight and the great circles appear curved. But we also view sunrise from the surface of the Earth. And as Brian shows here, the diameters of both these circles are large enough that when we see them locally, they appear to be two straight parallel lines. Now here's a great circle that I put next to a latitude line on Google Earth, and we're looking at it from an altitude of about 1,300 feet above the ground. So when you're at this location on the ground, both of these are 90 degrees to the longitude and they are parallel to each other. Now I've added an arm that is pointing due east into space, and again, from this location, these are three separate lines and all of them are 90 degrees to longitude and parallel to each other. So let's take a look at how the equinox sunrise actually works on the globe. So here I have two different locations along the terminator line where we observe sunrise, and I have great circle arcs that are going down to the sun's ground position, and of course this would be the zenith axis for the noon sun. So let's add two lines that are tangent to and 90 degrees to the terminator line, which of course would be the same longitude line on the equinox. Now since the radius of the Earth is 3,959 miles, this distance between the line continues as those lines head out into space. And that means that all three of these lines are parallel to each other. Now I'm going to use these lines to create two geometric planes which intersect the Earth along the Great Circle arc. And where the parallel lines at the top and the bottom intersect the terminator line is where due east sunrise would be observed. Now this is Brian's misrepresentation of the globe equinox sunrise with the sun on the GP. And as you can see, the line of sight from the terminator line would be through the Earth. You would not even be able to see the sun from that location. But look what happens when you move the sun out into space along the zenith axis of the GP. That angle between the line of sight to the sun and the lines at the top and the bottom gets smaller. And those angles get smaller and smaller as the sun moves farther out into space. And with a sun that is 93 million miles above the GP, well, those are parallel sun rays. And this explains why we see a sunrise that is due east anywhere along the terminator line on the equinox. And this also explains why the noon sun is at zenith on the equator on the equinox. Now, since lines of latitude are parallel to each other and they run east to west, it's pretty easy to understand why we see sunrise and sunset due east and due west of us on the globe. And finally, Brian, if you're going to prove a local equinox sun on the flat Earth, why didn't you use the flat Earth model instead of a misrepresentation of the globe? Well, I think it's pretty obvious why flat earthers don't want to be called flat earthers these days.